The third one that we did, the third one that we did was the 37 degrees. So when he asks you what direction is it, I don't know, can I answer that? It's too vague. And that's the key. And that's what he wants you to see. And that's why I want to help you with this, because it is a vague question. But because it's a vague question, we can also answer with a vague answer. Now, vague doesn't mean it's not useful, it just means more generalized. And so go back and look carefully at 1 and number 2, number 3. Oh, I said that wrong. I said number 3 was 37 degrees. That was number 4. Number 3 was at negative 70 degrees, 290, sorry. But look at that one. And look at the 5th one, which is 45 degrees. In fact, maybe I'll just look at the 1st and the 5th. They're the easiest ones to see. All of these have the same magnitude. Where is the direction? Yeah, and I hope that some of you are seeing it. The direction is halfway between them. You see, the first one is 120 degrees apart, and the resultant is 60 degrees. The last one is 90 degrees apart, and the resultant is 45. The second one is 60 degrees apart, and the resultant is 30 degrees. Now, the third one's a little harder to see because it's 120. And if you cut that in half, you're at 110. But it's actually the opposite side of 110 because you went all the way around the circle. So negative 70 is halfway between them on the acute side of the angle, not on the not on the bigger angle, not on the 220. So that's a little harder to see with number 3, but it's easy to see with number 2, number 1, and number 5, and that's exactly what they mean. Here's the point here, is if I represent it with my arms, if I put a force this way and another force this way, if they're the same magnitude, hopefully what you get out of this, and it will help you with the homework, and the idea is the resultant force will be halfway between them. And if I make the angle a little bit bigger, the resultant force is still halfway between them. And if I make the angle a little smaller between them, again, the result is halfway between them. So that's why I said probably half of you aren't going to really kind of comprehend what the author is asking. But that's a good concept to realize. Those two forces are same magnitude, and what makes sense is the resultant will be halfway between. It won't favor one over the other. Because watch question number 2. Question number 2 extends off of that. Question number 2 says, what if the two forces are unequal? Now again, he means unequal in magnitude. And the only one we did like that would be number 4. But then it asks again this vague question, what would be the resultant? And what you hopefully see is when we got number 4, when we got number 4, when we got 37 degrees, that 37 degrees is a little bit closer to the big one, right? Halfway between would be 30 degrees. The two of them are 60 degrees apart. And halfway between would be 30. But it wasn't 30, it was closer to the heavier one. Here's what it's trying to say, if I can do this with my arms here. If this is the bigger force, and then this is the smaller force, the resultant is favoring, it's a little closer to the bigger one. And that's what we want you to see. And so if we're doing a problem and we're looking at what's going to happen here and we have unequal forces, we're going to see that it is going to move somewhere between the two, but closer to the bigger one. And so if this arm is the bigger one and this is the smaller one, it's going to move this way, closer to the bigger one. It favors the bigger one. It's not halfway in between. And so that's how 1 and 2 fit together. And the third one is a lot like this. I'll just read it. It says, if the angle between the two forces is reduced so that they are nearly parallel. Okay, so what the author is saying is if I have two forces, so I'll use my arm, and it doesn't necessarily say they're equal, but I'll just represent them with my arms, which look like about equal length. Okay, and so if they're like at 90 degrees, one here and one up here, the resultant would be halfway between them. But what would happen if the angle between them was less than 90 as opposed to more than 90? See, 90 degrees is what we did on step number 5. And we got a result of 141. Less less than 90, like 60 degrees is what we did on number 2, and we got bigger numbers. Where more than 90, like we did on number 1, which is 120, we got something less than number 5. We got 100. In fact, when we even went further apart on number 3, we even got a smaller one. And what the author is trying to get at is that you hopefully kind of see this visual picture. That if the two forces are in the same direction, the result tends to get bigger and bigger and bigger and bigger. And the biggest it will ever get is when they're exactly the same direction. That is the only time where 100 and 100 would make 200, is when they're the same direction. As you get off of that, it gets less and less and less and less. And so in our case, when we were 60 degrees apart, we didn't get 200. We got 175. And when they were 90 degrees apart, we got 141. And when they were 120 degrees apart, we got 100. And when they were 220 degrees apart, we got 70. Anyways, so the author here is trying to say, as they get more and more parallel, the resultant gets bigger and bigger and bigger. And so that's the mental picture you want to have. Forces that are like this are working together, and the force is getting bigger. Forces that are like this are fighting each other, and the resultant is smaller. And that's all we have for today. We don't have any graphs or any other discussion questions, just those 3. So we'll call that a wrap. End of day 3 and end of lab number